So we'll start with Lex. Lex is a tool which helps you to do the lexical analysis. Fine. As such, Lex is an tool which takes in the regular expressions. The program, what you develop, write in terms of Lex is stored with .l extension, and you have an Lex compiler which converts it into an equivalent C program, and then we'll use the C compiler to go ahead to solve it out. So as such, Lex is an tool which helps us to write regular expressions and then do the required token separation much easier than what you do with the help of C or C++. So where do we really work it out? Is we work it out in terms of the lexical analysis. You have a source code where they have just taken in A equal to B plus C star D as example. And now how do I do it? I take A equal to B plus C star D as example. When I pass through the lexical analysis, it gives me a sequence of tokens. Maybe it puts me in this format: ID comma A, operator comma equal to B comma ID comma B, so on and so forth. Now we have just named in the tokens alone. A, B, C, and D are taken in as identifier 1, 2, 3, and 4. The rest is taken in as such. It is mapped with the token. It's not generating a token pair. Now, to go ahead with what is lexical analysis, what is its main functionality? The main job of a lexical analyzer is to break up an input stream into tokens so that you'll be able to understand it. Either they give it in terms of a token pair, or they provide it in terms of an expression where we'll be able to take it up and do it. So A equal to B plus C star D can be converted to an identifier. This they have taken at every operator, they have given it as a separate token. And that is why you have it as A as an identifier equal to as assigned token, B as identifier plus again as plus token, C as identifier, star as multiplication token, identifier, and then semicolon. Now, what does this do? This Lex helps you to quickly scan through your program and generate the token by matching it with the sequence of characters what is given to us. But then, so it helps us to tokenize the input stream. What are tokens? We all know about it. And how do I represent the pattern of a token? It is in terms of regular expressions. Now, for example, you have a code snippet of the source program which is given to us. Now, here is a code snippet where I have to identify the identifiers what you have given in the program. So now to start with, we have a set of lines which gives us the regular expression or the regular definition as such. This gives you the regular definition. What does it do? 0 to 9, we have defined it as digit. A to Z, both in uppercase and lowercase, we have taken it and assigned it as letter. Now, the first character can be a letter followed by a sequence of letters or digits. Fine. Now, if the input what you give matches this particular pattern, you print that particular context onto the output, identifying it as a token. So now what happens here? All these are regular expressions. Whereas you have a printf statement here, which are rules which has to be executed when the pattern matches the given regular expression, or when the sequence of character matches the given regular expression. Now, in this case, if you have a new line operator, where is a new line? If you have a new line operator as such, you print the new line. Okay. Now you have an lex, yylex, a predefined method. This function helps you to start the lexical analysis. Fine. So we have three parts in a Lex program which we'll be dealing it. To understand it, we'll give a sequence of regular definitions at the top, and then either you can use a regular expression as such, or you can use a regular expression with the help of regular definition. So when a sequence of character matches this patterns, whatever we give, the C statements, the program has to be written in a C programming perspective. So the C programming statements will be executed based on the pattern which has been matched. So if I find an identifier, you will print the identifier. If I come across a new line operator, I'll print a new line as an output. So now what is this? This Lex is a table of two informations. One is the set of regular expressions. All these are set of regular expressions. And the other one is the program fragments. This is one program fragment, and this one is the other program fragment. So Lex is a source. Lex source is a table of two informations. One is the regular expression, and the other one is the corresponding program fragment. Okay, now the next one. This table, which contains two parts, the regular expression and the program fragment, is converted or is translated into a C program. In spite of whatever name I give to this program, when Lex compiler converts it into a C program, it converts it into lex.yy.c. So invariably, whatever concept comes in, it gets converted to lex.yy.c, which reads an input stream, partitions the given input, and we'll see how all these things work. Okay, so you have the Lex program. Normally, for example, let me take it as sample.l. Sample.l is a Lex program which I give it as input to the Lex compiler. Whatever name Lex program has in, it gets converted to lex.yy.c. And this lex.yy.c will be given to a C compiler, and you have the output. Now, when you execute a.out, the file, you can give in a series of input for which a series of tokens would be generated. Fine. Now coming back. So if you just look at here, you have three sections in an Lex program. The first section is this set of definitions, and then followed by the transition rules, and the last one is the user subroutine. Fine. So you have a set of program, you have a transition rule, and you have a subroutine. Now, before we move into the other innermost part of the Lex programs and the various terms which you can use it, let us try to solve it out in real time. So you have we'll just move on to klabcarnia.edu. If you have your laptops, you can work with it meantime. Now I have already logged in onto the terminal. You will have many options, and one option is the terminal option, for which I have logged in onto. Okay, so now how do I work out with? I am supposed to open a new file, which you call it as, hope it's visible. If not, you can just let me know. Okay, you let me open a file which is already existing. So I am supposed to give in vi sample.l. Now, if at all you go ahead with a new name, you can say vi that name.l. .l is the extension which is used for a Lex program. Now I have the first set of definitions. Okay, now for these definitions, what am I supposed to do, and what am I supposed to do in this program? Given a sequence of characters, let me try to count the number of vowels and the number of consonants. Okay, let me try to compare or map with the number of, count the number of vowels and the number of consonants. So what we'll do is any header file and any variable which has to be declared has to be declared within percentage closing opening parenthesis and percentage closing parenthesis. Okay, so percentage opening parenthesis is must, after which I can have any number of hash include, followed by the sequence of variables. In vowels is equal to 0, in consonants is equal to 0, and then you end with percentage closing parenthesis. Okay, now here ends the definition. If I have to define any regular definition, I am supposed to define before it. So for example, we'll finish it up and then we'll modify it. Okay, so now for example, you have percentage closing parenthesis. I have defined variable for the number of vowels, which is int, the variable for the number of consonants, which is also int. Now you have completed the declaration part. And therefore, to complete the declaration part, you have 2 percentage symbols. And now what am I supposed to do? I'm supposed to define a pattern. So I have a pattern for the vowels alone, A, E, I, O, U, or capital A, E, I, O, U. If any one of these letters are there, let me increment the vowel part. Now I have another pattern. The another pattern is A to Z and A to Z in capital letter. And then you have an consonant increment. Now tell me, if I have A in my given input, to which of these patterns will A get mapped to? Will A get mapped to the first one, or will A get mapped to the second one? Can I have the input results on the chat box, please? My question is, I have 2 different regular expressions. One regular expression indicates only the vowels. The other regular expression is a set of vowels as well as the consonants put together. But when I read A, to which will it get mapped to? To the first one or to the second one? Can I have answers on the chat box, please? First one, okay. First. Okay, so it gets mapped with the first one, right? So now what happens? I have finished off the translation rules. When I say translation rules will have 2 parts in it. One is the regular definition or the regular expression. In general, it is the pattern. And the next one is the C programming for fragments or the C code snippets. So every translation rule will have 2 informations. One is the the regular definition. The other one is the C program. So till you end the input, you will have these things executed again and again and again. And once this translation rule is over, we'll ensure that we have reached the end of the translation rule by using 2 percentage symbol. Fine. Now coming back, we'll move, and then you have the C programs. Now we'll directly go on to int main method, but because we have, whenever you have to start your execution, the execution flow moves through the main function. So main function, the first statement in your main function is the first statement in your main function is yylex function, a call to yylex. What does this yylex do? Yylex is an predefined function which starts the lexical analysis. Okay, yylex is an predefined function which starts the lexical analysis. Now, when you come to the last part of the lexical analysis, you come to the last part of the input, then you come out of this yylex function and you try to print the number of vowels and the number of consonants. And since it's int main, we are returning 0. Now, you also have int ywrap. What does it do? This is another predefined function which returns 1 when you reach the end of input. So YYLEX goes on reading and matching patterns after the patterns. When will it reach the last part of YYLEX and the control? When will the control move on to the main function? And the control moves on to the main function when YY wrap assures that there is no more input to be read. So we have, if you just look at it, we have three sections. The first one is the definition part, which is ended off by 2% symbol. And then you have the definition translation rules, which is again ended off by 2% symbol. And the last one is a sequence of C program. Now, how do I execute it? Colon WQ, the normal way, what we already use. And then Lex is an compiler. Lex sample.l. Lex sample.l is the command which helps us to compile the Lex program. Once it gets compiled, we'll use GCC compiler. Now, where is it stored in? The sample.l gets converted to an C program, which is termed as lex.yy.c. So it is lex.yy.c. Now, even this program, the C program, is being compiled without any errors. And then we'll have /a.out. Now I can give in any inputs as such. Now, how am I going to stop giving the input? I'll give Control D to stop the input. I'll give Control D to stop the input. If we just check it out, I think I have only 4 vowels over here, A, E, and O. The rest are consonants, so it gets mapped onto 25. So it gets mapped with the best match among the patterns what you define. So this is your program, Lex program. Now coming back to the other constructs of your Lex program. So far, do you have any doubts? If you have doubts, you can say repeat whatever you want. The other one is you can also say raise your hand so that I can proceed to the next set. What about the rest? Okay. Okay, thank you. So we'll now move on. We'll move on to the next part. Now, similar to Lex, you also have another one called as YACC, which is YACC, which is termed as yet another compiler, which we'll be learning along with your module 3, along with your parsing. So now what really happens is Lex compiler generates a C code for the lexical analyzer. The other name of lexical analyzer is scanner, because lexical analysis is also termed as scanning. So the tool, you call it as lexical analyzer or scanner. Now, what does this do? As we saw, it uses the patterns that matches the input and converts them into string of tokens. Whereas in the program, what we have just seen now, it converts into, or it just counts the number of vowels and the number of consonants. The other way around, it tries to identify the tokens and gives you in terms of the count. Sorry. And then you have YACC. YACC is a C code which helps you in syntax analysis. Now, what will YACC do? YACC will implement all your context-free grammar. The syntax of a program will be implemented in terms of context-free grammar, which helps you to receive the token from the lexical analysis and helps you to create a syntax tree. So YACC program takes in grammar as input, converts it into a C program, and then requests tokens from the lexical analysis and converts it into a syntax tree. And that is what is shown in the next slide. You have Lex with lexical rules, YACC with grammar rules. You have 2 different compilers. You have Lex compiler, which converts this program into lex.yy.c. whereas you have York compiler, which converts the program into y.tab.c. And in spite of, irrespective of whatever name you give for the Lex program and the York program, both the compilers convert it into the given name, lex.yy.c and y.tab.c. So the input which is given to a lex, yy-lex, you is given back to YY parse. Every token is given as an input to YY parse, which gives you the syntax tree. Now we'll have a quick review of the different regular expressions what we use. We have operators, character classes, arbitrary characters, optional expressions, how do you group it, and the repetition and the definition, which we already have seen in our offline class. But then we'll try to recollect the different operators what we have here. Now, all the information operators in the first line are considered as operators by the Lex compiler. So you have a double quotes, backslash, opening, closing parenthesis for character, this cap symbol for the beginning of a line or the complement. We'll see it one by one. You have hyphen, question mark, dot, so on and so forth. So all these are operators. If it has to have a normal meaning, then you have to append it along with the backslash. So dollar has a normal meaning. If I have attached backslash dollar, it is similar to the normal dollar what we use. And then you have character classes. How do I do it? Either I have to write it as A or B or C. So it can be written as A pipeline operator B pipeline operator C. Instead of writing it that way, I'll write it as A, B, C within square brackets, and no comma should be given in between. When you put it within square brackets, every single character is taken as a single symbol. It is not put together. Every single character is taken as a single symbol, and then every operator meaning is ignored except for these three. We'll see how it works. So A, B gives you, there are a few examples. If it is A, B within square brackets, it is A or B. But then if I have to have a sequence of characters, this or this or this, then you have to use hyphen. Fine. Now the next one, it is either plus, minus, minus or plus. When it comes between A and Z, it directly takes you the operator meaning. When I give minus at the first, then it says, it finds out it is not something to something. It takes it as a minus operator. So all digits with the two signs, 0, minus 0 to 9. Now, any character which is not a letter, that is possible. So A to Z, if I say this part alone, A to Z, capital A to Z, represents all letters either in lowercase or uppercase. Now, if I have to identify a pattern, apart from lowercase and uppercase, you are supposed to use an cap symbol. Fine. So you have to use the cap symbol. Fine. So this is all about your character class. And then moving ahead, you have arbitrary characters. The operator character dot helps you to accept all characters except new line. So what if I give dot alone? It accepts all characters, let it be alpha the characters, let it be digits, let it be any special characters. It takes in all characters, matches all characters except the new line operator. Now you also have backslash 40 to backslash 170, which takes in these values as the ASCII values and map it with the given character what is given as input. So backslash 40 to backslash 176 gives you mapping based on the ASCII character set. So you have two types of arbitrary characters. The first one is dot symbol, which will map any other character apart from the new line. And backslash 40 to backslash 176 maps with the ASCII character set. Now, as we saw it in the previous class, this is again a recollection. 0 or 1 instance question mark, 0 or more instance A closure, clean closure, and A positive closure with 1 or more instance. You can also combine those two. This is optional and repeated expression. Now, what about the precedence of the operator? You always talk about priority and the direction in which every operator has to be sorted out. The level of precedence is all closures has the highest priority. Let it be clean closure, positive closure, or question mark. It has the highest priority. Before this, anything within parentheses will be given the highest priority, and then all the closures are given highest priority, followed by concatenation, and the last one is OR operator, the alternation one. So this is in terms of decreasing priority. So parenthesis has the highest, followed by any one of the closure operators, followed by concatenation, and the last one is OR operator. Now, from which direction to which direction should I apply? All these operators are left associative, which means if I have two operators with the same priority, I'm supposed to solve it from the left-hand side. The leftmost closure will be solved first, followed by the right closure. Okay, so that is how it is. The leftmost concatenation will be solved first, followed by the next concatenation symbols. Similarly, the leftmost OR operator will be solved first, followed by the other OR operators. Now here we have certain pattern matching primitives. It said dot, any character except new line is accepted. For new line, it's \n. All these are known to us. If I don't give complement within the square brackets, it indicates beginning of line. But if it is given, if the cap symbol is given within the square brackets, then you take the complement of what it is. Dollar sign indicates end of line. We know about ARB, positive closure, anything here. And now, if you remember your class, offline class, I would have told you that you cannot write A per 3, B per 2, and so on and so forth, which is not in a regular expression. But when it comes to an lex implementation, I can always define the number of instances. So A within curly brackets, value 3 indicates 3 instances of A together. Okay, so A, 3 A's can be represented as A within curly braces, a value of 3. And then you have A plus B. If it has to be taken in as a literal, you have to give it within the quoted symbols. Okay, now coming back, we were talking about the lex table, and we always said the translation rule has to be 2 parts. One is the regular expression, and the next one is the action. Fine, we'll just go ahead with 1 second. Fine, so you have translation rules. How many statements can I have? I can have any number of statements. Okay, so that is how it is. Now you have in your translation rule, you can use certain predefined variables. Those predefined variables are pipeline operator, echo in capital, begin in capital, and reject. Now echo indicates the action for this rule is applied, is taken from the action for the second rule. Now, for example, you have 3 things put together here. This is a translate pattern, which says either it is a space, or it is a tab space, or it is a new line operator. I don't have anything except for a semicolon over here. What does it mean? If I read a space or a tab space or a new line operator, you just don't do anything. Now I can split it them and take it up into the 3 different rules. What has happened? If it is in space or a tab space, or a new line operator. So all these three patterns has the same action. Either I'll put it in a single line or I'll put it in different lines. So if it's a new line operator, I have a pipeline operator over here. What does this mean? This means the action is taken from the rules which are given below. And then you have tab space, again and pipeline operator. So you have to still look further down. And then you have new line symbol where you just have a semicolon, which means when all these three patterns match, you don't do anything, you just sit simply. Okay, so that is what the pipeline operator is all about. Then what about the unmatched token? The unmatched token, which means if a particular sequence of characters doesn't match with any one of the patterns given. For example, this is the only pattern which is given in our program. What is the only pattern? This is the only pattern which is given in our program. And what if I type A? A doesn't follow into any one of these. Now, this A becomes an unmatched token. If I would have typed in a new line operator, or I would have typed in a tab space, or I would have typed in a space, then those three matches are termed as matched pattern because they satisfy the pattern what you have defined in your program. Whereas when I give A, it is an unmatched token. Now, this unmatched token, how can I take it from the input to the output? We'll be using a predefined variable termed as echo. We'll be defining a predefined variable termed as echo in order to take an unmatched token to the input. Now, if I have to reject one alternator, if it matches something and you're supposed to reject it, then you go to the next alternative. You just say, you go ahead, use the word reject. So here you have a pattern called as ping. You count the ping value and then reject it. And then it moves on, reject the this alternative. And you have a pattern which is ink. So now you will have reject over here and then pin. And then you will have reject over here. What really happens when it goes on to reject? Let us just check it out. Let me check whether reject works. Sorry, whether reject works in this set of code. Now, once I do this, now what happens here? You have AEIOU, which has been typed in, which only gets mapped with the vowels. It should not get mapped with the consonants. But because I have done a small change in the program, because I have rejected it, it is counted by vowels. Now the same pattern has been rejected by this pattern, but still the other expression holds. If I put it reject in the first place, vowels will not be incremented, but it is also considered, and then it gets matched with the consonant part, and then it says the number of consonants is also 5. Okay, so that is how it works in. Okay, so that is how the reject works in. We'll move on to the next part. You have some more predefined variables. The predefined variables are YY text, which helps to define a string, or it holds the value of a string containing the lexeme. And whatever string you have in the lexeme, the length of the string is given in by YY You need not find the length of the string. If I use a variable, all these are predefined variables. And if I use YYLen, then you will have whatever you have, the length of whatever you have in YY text. Then we also have YY in and YY out. These are input stream pointers and output stream pointers, which mainly map onto the standard input and output. And you can also read from an input file and write it onto an output file. When I say /a.out, instead of giving it onto the console, I can say less than the input file name. And then you can go ahead, write it on to an output file name by using greater than out file. So you have echo, you have YY length, and the length is added in terms. So what does these examples do? If a pattern is matched, YY text will have that pattern which is being matched. And then if I have to print it, you have the value echo, which also does the same. And the last one is you take account of the length of every string and add it on to the characters. We already know about YYLex function and YYWrap function. YYLex function helps you to start the lexical analysis, whereas YYWrap function indicates that you have reached the end of file and you can move for other statements to be executed which are there in the main function. Now, if I have to read more number of tokens, you can always use YYMore function. YYMore function returns the next token so that you'll be able to do it. Whereas YYLess retains the first n characters in YY text. So YY text already has a sequence of characters. If it has to retain it and then match it with the next set of patterns, then you have YY less of n. N is the number of first n characters, not the last n, not the trailing n, but then it is the first n characters of YY text as such. Now, this is a general, concise, predefined variables and functions. So you have YY text, YYLen, in, out, lex, more, less, and wrap. Echo, reject. Initial is another keyword which moves on to the first condition, initial condition, and begin. It is a condition where you have a switch case and you start at a particular point of time. And now here we'll move on to the examples. Here you try to identify a letter. So what happens? In addition to main program YYWrap, if any other functions has to be defined, you can always declare it in the definition part. So you have %:void foo is a function. You have declared that foo is a function with no inputs and which returns nothing. And then you have the pattern, regular definition. You end off these two with 2 % symbols. And once you come out, in the later part, in the auxiliary session part, you will define the functionality of foo. So now, what does this really happen? We have a counter. We have a variable where counter is being initialized to 0, which is of integer data type. You are defining only a sequence of letters. And then you have, this is the first part. This is your regular definition part. What all things can I define? I can declare all the header variables what I use. The variables what I use, I can initialize those variables. And I can also define the signature of the functions, user-defined functions which I use in the program. I'll repeat. In between % opening parenthesis and % closing parenthesis, you can define 3 things. One is the header file. Second one is the set of variables. Third one is the functions, whatever you define at the later part, user-defined functions. And then you are followed by which you can define all the regular definitions, what you want to. Once all these declarations and definitions are over, we'll end it up with 2 % symbol. Now, letter ++, you just increment the word, you print it and you increment it. Every time you have letter ++, you print a word is there and then you increment the count. Now there ends your translation rule. So I have again completed it with two percentage symbols. You are adding to the main method. The first line of your main function would be yylex. And then if it is yin, you have to read it from that file. And then you go ahead with yylex. So you print it and there ends your program. Fine, this is all what we have talked about. You have combined it, you have put it onto some input, so on and so forth. Fine, we'll just take one more example and see what that example has to tell. Fine, here I have a program where I try to talk about word, blank space, end of line, and any other character. So now what really happens here? I have three variables which has to be defined. So now you have percentage, you have included the header file. I have included four variables for four different counts, and there I ended. So this part comes to the end of the declaration of variables and header files. Now I am declaring four other regular definitions. For word, if anything apart from the space, tab, new line operator, dot, and semicolon, comma, it is considered as a word. End of line, how will I find it? If it is a new line operator, I can consider it as an end of line. Blank space, you just give square bracket, within that you given space to it. And then there ends your regular definition part. So I given the end of it by 2 percentage symbol. And then now we'll go ahead with the word count. Word has to give a word as such. If you find it out, you talk about the count of word. You also increment the character as such. So you can take the character, take the length of the word, what you have mapped in, and add it on to the character. You need not find the length of the character as such. Length will return the number of characters in a given string. If there is a blank space, you add S value by 1. If it is end of line, you add L value by 1. If it is any character, you go ahead with C++. And then moving on, you come to the end of translation rules, you finish it off. You have int wrap, which helps you to point the end of line. A void main, you start with yylex because that helps you. And then all these comes in one line. It's just because of wrapping. Okay, you print all the characters, words, spaces, and the number of lines and have an end to it. So now we'll try to execute it. Control D will stop it and it prints out stop the input and it prints out all the other information. Fine. So we have come to the end of Lex. Lex helps you to define different program, regular expressions and move out. If you have any clarifications, you can stay back or else you can leave. Thank you, ma'am.